Okay, so our material for today is going to be covering, again, 3.6, working with applications, and as you can see from the original, from the first slide that we have there, first header that we have, working with story problems. Now again, I'm hoping it's been made abundantly clear up till now, but again, I can only say it so many times and try and emphasize it. We're going to be doing a lot of prep work for these story problems before we get it down to an equation. So we do not want to rush our process when we're just going through and trying to figure out, okay, how can I set this equation up for myself? What could I, how can I write these things out as expressions, equations, anything like that? So again, the proposed strategy that I'm giving you guys that I think is worthwhile using, you do not have to use it, but again, I think this is a fairly universal set of steps we can have for solving and setting up these story problems. And again, I want to emphasize how many of these are actually just doing setup steps before we actually get to just doing a pure mechanical problem. So again, first and foremost, read, reread, and reread the problem over and over and over again. It cannot hurt you to keep reading this thing until you get a better or solider, perfect understanding of what exactly is going on in the problem, what's the relationship between the variables, what's the relationship between the numbers, what numbers are useless, which ones are useful, anything like that. And again, go back and repeat this as necessary throughout the process. A lot of people try and I'm just going to read the problem once, write something down, and I'm good. And no, go back and reread it if you have to. There's nothing wrong with that. I'd recommend at that point in time also pull out important information from the problem, label any variables or numbers that you are using to represent something. Okay, I'm going to use the variable x. What does x represent? Is that a dollar amount? Is that the length of something? Is that the height of something? Is that time? Label your variables. Numbers are also pretty important. Use the units that are attached to them. It's pretty helpful on that front. And then also define what you are solving for in the story problem. Am I looking for a length? Am I looking for a time? Am I looking for a dollar value? Things like that. Drawing pictures is pretty helpful. It doesn't necessarily lend itself to every single problem, but it's pretty useful, especially when we have geometrical problems showing up like we have with example 1. So we'll go through an example with that. And I think steps 2 and 3 kind of go hand in hand pretty well. Pulling out some information, maybe I know the length of something, maybe I know the width of something or the height. Draw a picture of that shape, whatever it is that we're working with, and then label what that looks like in that shape itself. So again, 2 and 3 going hand in hand here, and then reread as necessary if you're a little unsure as to where you should label these things, where you should put the numbers, anything like that. Step 4, we're going to set up and adjust equations. So as we've done with some previous story problems, we might be working with the perimeter of, I think we had a perimeter of a triangle showing up on the first test. So let's get the general equation for the perimeter of a triangle written down and then go in and adjust it. Do I know the perimeter? Do I know side 1, 2, or 3? So making an equation, modifying it as we go along in the process. There's nothing wrong with doing that. And then once we have it adjusted accordingly enough to, okay, here's what we want, here's what we're solving for, this all looks accurate, then we can actually solve the equation. So again, if we're looking at all the steps that we have here, 2/3 of this is just doing a lot of setup work for ourselves. A lot of people will read this and say, okay, yeah, well, I've been given some stuff, I'm just going to put some numbers together. Yeah, I guess that sounds decent. And you don't want to do that. The entire problem hinges on you doing these first 4 steps correctly. So do not rush yourself as you're going through this process and setting that up for yourself. Once we have an equation set up, we're just pretty much doing what we've done in 3.5. We're just solving that. Solving for whatever variable is listed, solving for x or y or whatever you set those to be, and get our answer or answers in some of these instances. And then last but not least, check to see if the answer is reasonable. Again, if we're asking for the length of something and we put our final answer is a negative value, is that reasonable in the context of the problem? Is it reasonable for me to have a negative length if I'm measuring something? And no, it isn't. So something may have gone wrong there if we're checking our answer on that front. Okay. So in a lot of the stuff with a lot of these story problems, it's the first 4 bullet points that I think Our first 4 steps, I think, are the most important with this. And at the same time, admittedly, the most challenging. How do I set this thing up? How do I find the relationship between these 2 variables, these 3 variables, or the numbers that I'm working with? It's all understandably difficult. And I get that, which means you should not be rushing your process. You should not be just quickly flying through it. Okay, I've read it once. I'm just going to make an equation and go with it. Don't be doing that. We want to work up to being at that point. But if you're not at that point right now, that's fine. Just be aware of that as you're going through and solving these things. Okay. So we're going to take a look at 3 examples here. I'm going to jump us over to the whiteboard as we go through these, but these are the 3 examples that I'm referencing here. So our first example is telling us the perimeter of a rectangle is 42 feet. The length of the rectangle is 1 foot longer than the width. What is the length and width of the rectangle? Okay. So as we're going through this, and I'll do this here for now, but we are going to be going over to the other whiteboard to go through and work with some of this other information. But as we're going through this, we're trying to see, okay, are there any buzzwords or anything particularly useful that's standing out to us? Well, we're told something about the perimeter. We're told the length is 1 foot longer than the width. There's some buzzwords in there, longer than, so it's probably going to come in handy. And then what is the length and width of the rectangle? So length and width. So I'm going to need 2 answers at the end of this problem. I need the answer for the length of the rectangle, and I need an answer for the width of the rectangle. So I should be having 2 answers coming out of this. If this was the test, I'd be probably giving you guys the length equals, then a blank box, width equals, and then a blank box, making sure we're filling those in correctly. So this is what we have here. This is the problem that we're working with. I'm going to jump us over to the whiteboard, and we'll go through and actually set this thing up and write some things out in that regard. Clear those. I'll jump over here. So again, we're working with example 1. So we are told the rectangle, the perimeter of a rectangle is 42 feet. So I'm going to, where is it? There we go. I'm going to make a quick rectangle of this thing. About like that. Cool. Let's see if I can move this here a little bit. Perfect. Okay, so I have a rectangle that's showing up. I don't need any of this. Okay. We are told the perimeter of a rectangle is 42 feet. Okay, so stuff that we know. We know the perimeter is 42 feet. Okay. And again, there's that subtle buzzword in there. The perimeter of the rectangle is. That is a buzzword for the equal sign. So perimeter is 42 feet. Again, very subtle, but we want to make sure we have that wording down. So again, if you have not downloaded or take a look at that English to Algebra page that I gave you guys, extraordinarily useful on this front. Okay, so the perimeter of the rectangle is 42 feet. The length of the rectangle is 1 foot longer than the width. Okay, so we can also label our rectangle here a little bit. So we have our length, we have our width. You can label all the sides if you want to. But now again, we're translating that sentence we've been given. The length of the rectangle is, so is our equal sign that kind of divides this sentence in half. The length is, so equals, 1 foot longer than the width. So whatever the width is, it's 1 foot longer than that. Now again, right now, I do not know what the length is. I do not know what the width is. Those are unknowns. That's what we are solving for. We're asked then, what is the length and width of the overall rectangle? So I will need to have an answer for the length and an answer for the width, which is fine. We're still building this thing up. We're going to keep track of where we're going now. So working with the perimeter, if you need to, again, there's a file that has a lot of the geometric shapes and their equations that go along with that. We are going to likely need the equation for the perimeter of a rectangle here. So that equation, and again, you can reference that on the geometry notes if you want the full summary of all of those. It's a better choose here. Okay, the perimeter of a rectangle is 2 times the length plus 2 times the width, essentially adding all of the sides together. Now we have been given the value of the perimeter, so we know the perimeter from up here, which means you can plug it in for perimeter down here. And I'm going to rewrite that in the line below. So all I've done is just rewritten that, the perimeter, knowing that value. And at this point in time, we're noticing that we have 2 variables showing up in this equation, a length and a width. Now, everything we've learned up to this point in time, primarily from 3.5 with solving equations, we can only have, or we're used to only working with one variable in an equation, mostly because that's the only way we can solve these things to actually find values. So what we are going to do is we are going to take, I'll use green for this, we're going to take our value or our equation that we created for the length, and we're going to be plugging that in for the length in our problem, essentially substituting this. I'm going to move us up here a little bit. So when I substitute that in, getting this equation that we have here. Now again, in the context of this problem, the length is the exact same thing as w plus 1. So I have written the length in terms of the width. And that's what we solved for originally up here at the very top, because we were given some information about that. And now looking at our equation with where it is currently, we're seeing, okay, I've got a number on the left-hand side, and I only have one variable on the right-hand side. It's w, instead of the line before where it was L and W. But because I just have a single variable now I can go through the process from 3.5, simplify both sides, and solve this thing for our width. And that's exactly what we're going to do now. So I have 2 times the quantity w plus 1. This is now just a mechanical problem using our 3.5 material. So we're simplifying both sides of the equation, combining like terms as necessary. I can combine the w's together. And now that I've done that, we want to isolate our variable terms to one side of the equation. Well, that's already done for us, so we're good there. Now I want to get rid of all the constant terms on that side, so I have a w over here, and it has this plus 2 attached to it. I want to get rid of that plus 2 by subtracting 2. So I subtract 2 from both sides. I do not want that 4 attached to the w. It's attached through multiplication, so I'm going to undo that with division. Move this up here a little bit. And we are getting that our width is 10 feet. Now again, this is where I want to emphasize, what were we asked to solve for? And we were told from the problem itself, what is the length and width of the rectangle? So we just found the width. We are not done yet. We still need to find the value of the length. I'm just going to move us up here. And what's really nice with how we set this up for ourselves, we have an equation for the length. So I'm going to rewrite that down below here in the general form. Have our prep work there. So our length is equal to the width plus 1. We know what the width is, so we're just going to plug that in. So 10 plus 1, that's going to give us 11 feet. So our length is 11, our width is 10. We are good to go on that front. Okay. So again, it's not always going to be the case, but if you have the opportunity to draw a picture for a problem, I would highly recommend that you do that. A great visual, or even just a very simple visual on some of these things, can go a really long way with what am I looking at in the problem? What am I being asked for? What's the general setting of this thing? Makes it so it's one less thing that you need to keep track of in your head as you're going through and solving these problems. Because there's enough going on with these already, we should let the piece of paper or whiteboard or whatever we're working with do a little bit of that work for us. At least that's my thought, or what I would recommend we use for that. Okay, I'm going to jump us back to our notes so we can take a look at the new problem. And then we'll come back over here to build some stuff with it. Oops, there we go. Okay. So our second problem, we're told Blizzard has been selling 2 different versions of their video game Overwatch for a limited time. One is the original version, and the other is a special edition that comes with 25 unique unlocks in the game and costs $15 more than the original version. After 2 weeks, 500 copies of the special edition were sold, and 1,500 copies of the original game version were sold. Blizzard earned a total of $77,500 at the end of these 2 weeks. How much did each version of the game cost? Okay, so we have a lot of information going on there. There's a lot to digest, a lot to process, all of that. And if you're someone who is going to say, okay, well, I've been given this stuff, I'm just going to write an equation down and just go with whatever sounds good on that front. I'd be very, very, very careful on that. These are the types of questions that I like putting on the test, where there's a lot that's going on with them, and if you are going to rush yourself, it's going to make life very difficult. Okay? The goal that I want for you guys is you guys be significantly better, more comfortable, or having strategies or working with story problems, because a lot of people will actively avoid doing story problems if they can help it. And here's a spoiler for you guys. All of the math classes you're going to take in the future are going to have story problems. So there's no point in avoiding them or trying to get out of them because they're not going away. So I'm going to jump us back to our whiteboard, but this problem 2 is the one I'll be referencing. It's a bit hard to jump back and forth and keep everything in line, but if you do have the lecture notes up somewhere on a different screen for yourself or on your phone or something like that, this is what we are referencing as we're going through this. So for our second problem, again, we're told Blizzard has been selling 2 different versions of their game, and overall we're trying to determine how much should each version of the game cost. Okay. So we have a certain amount of each type that's being sold. So we have our, where am I at here? Okay. So again, trying to pull out some good information that we have and cross out information that we don't need. So rereading the problem again, because again, there's a lot going on here, so don't rush this process for yourself. So Blizzard has been selling 2 different versions of their video game, Overwatch, for a limited time. One is the original version. The other is a special edition that comes with 25 unique unlocks in the game and costs $15 more than the original version. So looking at it, we've been told 25 unique unlocks. That doesn't necessarily pertain to our problem, so we're not going to need it. We're told after 2 weeks, 500 copies of the special edition were sold, and 1,500 copies of the original version were sold. So that's some useful information. We know the amounts of each version that were sold. So we have, whoops, come on, pen, work with me. So I have 1,500, the original sold, 500 special ones sold. Oops. Hopefully it's becoming abundantly clear why I did not go into teaching English or language arts or anything like that, given how I'm spelling everything today. Okay. So we know the amounts of each that were sold, so that's going to be useful. So we are told within this as well, again, rereading the problem, they have, let's see, original version, the other is a special edition with 25 unique unlocks. We don't care about that. And costs $15 more than the original version. We're trying to find how much should each version cost, and we currently do not know that. So once again, we are being asked to find two things for this problem. We need the price of the original version, and we need the price of the special edition. And we do not know what those are, which is fine, but we are going to set those up and define some variables with that. So I'm going to use X and Y for this. You can use whatever variables you would like. M and N, A and B, it's your call. But whatever you're doing, I would make sure you are writing it out for yourself and labeling these things. So X is this, in this case, is I'm going to say it represents the cost So I'm going to say X is the cost of the original version, and then Y cost of the special edition. So again, I do not know what those values are right now, and that's fine, but we're just doing all of this prep work for ourselves. We're taking this in parts and saying, okay, how could I put this together? How can I put that together? Things like that. And again, if you're trying to rush yourself in this process, so you're saying, Alex, you're going really slow in this, it's because if you're very methodical as you're setting these things up, as soon as you get to an equation, the rest of it is very quick and easy. At least I think so. In terms of, I shouldn't say easy, it's more mechanical. And there's less room for variability with that. Okay, so we have our amounts of each that were sold. We have the cost of each version that we have as well. And then we're looking through this to see what else we've been given, or information we've been given. We're told Blizzard earned a total of $77,500 at the end of these 2 weeks. How much should each version of the game cost? Okay, well, trying to make an equation out of that. They earned a total of $77,500. So we should have if we were to take however much of each version that we had at their given price, and we combine all of those numbers together, the dollar value should be that 77,500. So let's translate that into an equation. So we know our result should be 77,500. So now setting this thing up, this is where our numbers and variables need to align for ourselves. We have 1,500 of the original sold. And what's the cost that's associated with them? Well, we don't know that, but our variable X tells us what that would be. So 77,500 is equal to, well, however many of we have 1,500 original sold at some price. So this is going to be some dollar amount plus the amount of money that was made from the special edition. And all that we know is that we're 500 sold at some price Y. Okay. So this is working with our totals. So the total amount that we earned, or that was earned from the original version in dollars, plus the total amount that was earned from the special edition in dollars, combined together to give us our total earnings of $77,500. So what's great about this, we have an overall equation that tells us the cost based on everything being, or the total income being added together between those two, which is great. However, we are currently running into the issue of I have two variables on the right-hand side. And it's impossible for me to solve this equation as it currently stands with two variables in the equation, two completely different variables, I should say. So I need to determine, is there any information in the problem that tells me something about the relationship between the cost of the original edition and the special edition? So I'm going back and rereading the problem, okay, because I want to try and find any other bits of information that I need out of this. So we're told one is the original version, and the other is a special edition that comes with 25 unique unlocks in the game and costs $15 more than the original version. So I've just been given some information about the relationship between these two costs. I've been told the special edition costs $15 more than the original. So setting that up as an equation. So it's going to be y equals, I'm saying, what is the cost of the special edition one? Is $15 more than the original version. So if I know what the original version is, I'm adding 15 to that. It's a better one here. And that is going to tell me the cost of the special edition. So now we have our two equations that we could potentially be using in this. And primarily, the bigger kicker we have here, we can substitute what we just found, we just made, in for y in the other equation. That's going to make everything all in terms of x. I only have a single variable that will be showing up then, and I can solve the equation that I've been given. Okay. So in doing that, I'm just going to underline our y here. Draw this so it's a bit cleaner. And now we're going to rewrite our overall equation. That substituted value in. So now I have an equation with only one variable type on here. I'm only working with x's now, and now I can solve this thing using the methods that we learned yesterday from 3.5. So from here, I'm just going to be using the distributive property. I am simplifying both sides of the equation before I start adding or subtracting things back and forth. And again, I cannot emphasize that set of steps enough. Simplify the left-hand side, simplify the right-hand side, and then start moving things back and forth. Because there's a lot that's going on the right-hand side, and you do not want to get lost in it. I'm doing part of this step, part of that step, part of a different step. Simplify it before you do anything else. So working with 500. 500 is going to distribute through to everything on the right-hand side inside that parentheses. So 500 times x, it's going to give us 500x. And then 500 times 15, I don't know what that is off the top of my head, so I'm going to plug that into a calculator for myself. And you are welcome to do the same thing, either be on the homework or the test. And big numbers, so absolutely write that in for yourself, or use a calculator to help out with that. Totally good with that. Nothing is happening to the 77,500 on the other side, so it's just going to come down. On the right-hand side, I can still combine like terms. I have two x terms over here, so combine those together. Actually, we'll do this. It's easier to see that there. Okay, so 1,500x plus 500x is going to give us 2,000x. Nothing's happening to the 77,500, and nothing is happening to the 7,500, so they're just coming down as they were. And now we can solve this thing mechanically the rest of the way out. So I have my variable term isolated to one side, or it's on one side, I should say. And now I want to isolate it all the more by getting rid of this 7,500. Again, we're following our 3.5 process. So I'm subtracting that 7,500 from both sides of the equation because I want to get x by itself. Oops. Keeping the colors accurate here. On the left-hand side, again, if you need to use your calculator to go through and subtract those things, I'm going to do that just to make sure I'm not screwing up anything else in the problem. We're getting 70,000 on the left-hand side. And now from here, I do not want 20,000x, I just want x. So I'm going to divide both sides, 20,000, 2,000, I should say. So I'm dividing both sides by 2,000. Whatever we do to one side, we have to do to the other. So those ones there. Again, 70,000 divided by 2,000. Use your calculator if you need to. I'm getting 35. I'm just going to put the x on the right-hand side here. So we have our x value. Yay! Have half of this thing done. And again, we have half of it done because we were asked how much did each version of the game cost. So let's go back up on our problem and find out. Okay, so just a reminder for ourselves. What does x represent? Okay, x represents the cost of the original version of the game. So we have that labeled for ourselves. And again, it's very useful to have your variables labeled so you can keep track of what did I just find? What am I looking for? What do I have left to find? And thankfully, we also have an equation for ourselves that can tell us the cost of the special edition, which is what we made originally. So I'm going to rewrite that off to the side because we need the cost of the special edition version. Oops, come on, there we go. We were told in our equation is written out as y is equal to x plus 5. So that's all I'm doing is rewriting that over here. X plus 15, I should say. I know the value of x, so I can plug that in. We had 35 for that. And now from here, I'm just going to combine like terms. I have 35 plus 15, and that's going to give me 50. And we have our final answer here. So we know that the special edition of the game, which is represented by y, costs $50, and the standard, or the original version of the game, costs $35. So we have our two answers there. So I can zoom us out here a little bit. There we go. Okay. So that is our setup and our process for the first two problems that we have in 3.6. I am looking at the time and I do not want to rush the third problem, so we will get to that tomorrow. But I am going to pause or I'm actually going to stop the recording here, and I'll open it up to any questions that you guys have with how we set these things up or otherwise. Again, we are not done with 3.6. We will finish the last of it tomorrow, which is with our third example. So I'm going to end the recording. I'll take any questions that you guys have about any of this, and we will go from there.